which one you didn't get, and we will sit there and work those out. When you're looking for infinity, that's the one that is the same as your horizontal asymptote, because that's what guides your end behaviors, are your asymptotes. So those rules apply. If they're the same in the numerator and the denominator, make a ratio. And our asymptote would be y equals 1/4. All of your limit just says it will approach 1/4 as it keeps on going forever and ever. So just be careful of that. Some of you don't get the concept of a conjugate. A conjugate says the conjugate to this guy is x plus 2. Keep the same first term, keep the same last term, but change the sign in the middle. The conjugate to this guy would be what? X minus 4. The concept of the conjugate is like your perfect squares. It eliminates your middle term. Don't change the first one. And what happened on the test, the radical was second. So when it comes out of radical and it has a minus in front of it, you have to put parentheses around it. I think that's what a lot of you forgot, were the parentheses. So it kind of worked out at the end that your denominator came out to be 0 anyway. So I just took off a point. It was worth 4, somewhere along the line, either 1 or 2, depending on what you did with it. Again, slide this over. Don't distribute it, because your goal is to get rid of that x on the bottom, because you can't put a 0 in there. Once you get rid of that x, then substitute your x in, and it will work. Stop me if you have any questions. Factor and reduce, this is your point of discontinuity. So technically what you're doing is you're saying, well, I'm discontinuous here at x as -3. But it's just going to be a little bump in my road there. It's just going to be a little point that I'm going to just jump over. So if I could remove this, I would reduce this down, plug in my x, and there's my limit. It would approach the y of -5. And you can graph this as well. You can graph it as well. This one was not factorable, so there's no way we can reduce that x plus 3 in the denominator, and if you graph it, you see that it's discontinuous. Try and graph a lot of these, because, I mean, I like to graph them first, because it kind of gives me a heads up on what I should expect. And if it's there, like in letter E, I can just go to my table and look what 3 is, and know the value of y, right, if I graph it. It's the same function. So I can just go to my table and pull out my value of 3, and there's my y. That one has a limit. It's there. Okay. Did we do this one together or no? This one we did, right? Yeah. Because this was a way of connecting what we did in the past, like in the fall, to what we just did with your limits. So is it kind of gelling together now a little bit better? There's kind of like no way for us to talk about the limits at that point. But I keep like alluding to it, hoping that it'll make sense when we come back to it. And again, graph this. You can see it in your graph. Factor it. The factor that you reduce is your point of discontinuity. This is your redefined part without that point. That's a removable point. The x plus 2 gives us an asymptote of x is equal to -2. That cannot be removed. That has no limit at -2. That's going to be like without bounds. It's going to go the other way. They like repel off of each other. Some of these are just like things just to look at. Does the limit exist? This will, even though this is open, this is a point that we could fill in. It approaches the same point from both sides. I don't honestly know what happened here. Something's going on with the word thing here, because I don't even know where this came from. And it's all pushed together. do it on my computer. So I don't know what's going on in there. So this has a point of discontinuity if you factored and reduced it. This guy too. This has a limit. Plug in the 2. You can tell by the denominator we have no domain restriction for 2. 2 is going to work. Negative 2 will not work, but 2 is going to work. So substitute it in. And that's your y value or your limit. Or put it in your calculator, go to your table when x is 2, and pull out your y value. And this has no limit because it's not connecting. It's not going to meet. It's jump. This is a jump discontinuity. Were there any questions on these? No? What's next? 5? Oh, 5 are your conics. And your transformations. Do you remember your transformations?
Vaguely.
Vaguely? Yes. Phase shift. A phase shift is this in here. Whenever you have like a cosine sign, any kind of angle shift in here, it's this. This is what's happening in your phase shift. Your phase shift, again, some people say negative A over B. I just say A over B, and then we say this is moving to the right, goes the opposite way. Like this one, where is this one moving to? This is the horizontal shift which way? To the right. Anything in the parentheses, under the radical, set that in the absolute value, bars, shifts the opposite way. So this is also going to go the opposite way, but we call it a phase shift because technically it's shifting to where your angles are going. It's shifting, no different than a horizontal shift, but because that 3 is there, we have a lot something else going on besides that. So we call it a phase shift. And A over B. B over is, I think it's B over A. Can't be A over B. Because this should be A, this should be B. I think it's B over A. I think this is wrong. So it should be B over A. And it's just like, and some put the negatives out here, to take the opposite way. So just remember, first you're looking at which way is this going. We have, we all have to use the same words on this. Your conics, I know they're a little tough to recognize, but before you even start your conic, decide what it is first. There's only one square. So one square is parabola. If it's a y squared, which way is it going to open? To the side. I don't know yet what P is, if it's positive or negative, but I know that I have a parabola because I only have one square. 2 squares are going to give you a circle, ellipse, or hyperbola. So the best way is to set this up first so that you don't forget where your P is. Try to memorize that one. That's on your formula sheet. So I know you don't get your formula sheet, but at least it helps you remember which ones am I supposed to be familiar with. Complete the square. You only have one square to complete. Move these guys. Be careful when you move them. Make sure you take the opposites. Complete your square. This is your 4P right here. So this tells you that it's opening facing the negatives to the left. And P is 2. That helps you with your vertexes in there. Your directrix is your P distance. Your focus. You guys dismissed the algebra 2. Algebra 2 now does focus and directrix. Then algebra 2 now does this. So now next year we can take this out of precalc. Again, I don't know what this thing is doing. It's kind of condensing my work here. I don't know if you can see through it. Okay, so make sure you label everything. This one, you see two squares. They're both the same sign right now. Whether they're going to change, that they can't change to both negatives, but they're both positives right now. This is an ellipse. So get your x's together, get your y's together, complete both squares. Don't forget, this is a key thing. If you factor something out, don't forget to distribute it back out. And then set it equal to 1. I think the ellipse is probably the easier one for you guys to recognize and to deal with. It kind of makes more sense because then you can say which one is bigger. So underneath the y is bigger. That's your major axis. Find your center. Find your focus. Remember this for foci. Remember that guy. And it kind of makes sense. It's the same as your Pythagorean theorem, but if you want them inside, you're going to subtract to get them inside. If you want them outside of it, you're going to add to bring them outside. So if you did it the wrong way, your foci would be sitting out here, and you'd say, "Whoops, that can't be out there. I must have to subtract those." And on the final, they'll ask for a specific part. Find your center, find your vertices, find your foci. We'll label which parts we want you to find. Make sure you give me all sketches. If it says sketch, make sure you sketch. And we have a detailed rubric just like we do with your tests. I'm a little bit more lenient on the rubrics than Ms. Fernandez is, but we're all grading together, so make sure you give me all the parts. Good? Questions? Okay. And again, I wouldn't memorize those formulas for vertex and foci. I would just use your graph. This, we know two squares, and their opposite signs. This has to be a hyperbola. Hyperbola, get your x's together, get your y's together, put the 16 on the other side. This is a negative 16. I think my negative sign got stuck in my equal sign. So get everything to one side, complete your square. Now, if this is fine, we're dividing by a negative number. It's just going to flip these around. Always put the positive one first. And this is your major, whoever comes first, the positive one. The ellipse doesn't matter because it's commutative property. It doesn't matter which way you add, but it does matter which way you subtract. And again, your foci adds it so that it puts it outside. And don't forget your asymptotes.
How do you asymptotes for
Asymptotes, real easy. They're, take whatever the y is, and the y is by itself, they're lines. So if it says y minus 2, we're going to put y minus 2. It technically says y minus 0. So we just, y minus 0 is that. This is your plus or minus, this is your slope. Slope is change of y over change of x. So go underneath the y and take the square root of that, 2. Go underneath the x and take the square root of that, radical 3. So 2, radical 3, and then put the x guy. That's it. If you have anything else, put the guys in backwards. This is backwards. That's backwards. It should be 2 over radical 3. If you have anything else here, like if it says y plus 2 equals blah blah blah, just make sure you move that 2 over, make sure it just says y equals. This one doesn't because it's just 0. Try not to memorize too many things. Try to get a feel. And you can also find your slope like this, up and over. So you're looking at your change in y, so you kind of look under the y first. You're looking at your change in x, you look underneath the x. So that'll help you to remember which way the slope goes. Make sure you put the plus or minus because you have two asymptotes. Good? Are we good with this one, or do you have any questions?